Right, in our last example for section 3.4, we are going to compare some different data distributions. When we are comparing our data distributions, we are going to want to be sure if we're making comparisons between two totally different sets of data, that we actually want to use the same measure of center and spread for both distributions. So if we're comparing two different sets of data, we want to make sure we choose and we kind of go with either our mean and our standard deviation or our median and our interquartile range. If one of our distributions is skewed, so it doesn't matter if all of them are, but if at least one of our distributions is skewed, then we're going to use our median and our interquartile range to compare our distributions, because as we saw in the last example, they're more resistant to outliers. If all of our distributions are bell-shaped and symmetric, then we're going to use our mean and our standard deviation. So looking at this last example here, the histograms show the difference in finishing times between an amateur marathon and a 2012 Olympic marathon. Use the diagrams below to answer the questions. What shape are each of the graphs? So looking at this one, we definitely have kind of a tail going off here. So we would say that this is, we could throw in the word slightly if we wanted to. It's not as skewed as we've seen other ones, but slightly right skewed. Where this one also appears to be slightly right skewed. In some ways we could make an argument that maybe one of these is roughly symmetric, but there's definitely a tail for each of these, so both of these are right skewed. All right, should we use the mean and standard deviation, or should we use the median and interquartile range? In this particular case, we are going to use the median and interquartile range because at least one data set is skewed to the right. Right, so since at least one of our data sets is skewed, we're going to use our median and interquartile range because they are more resistant to our outliers. What kind of comparison can be made? If we actually look at the times that are listed on here, notice that they do have the same exact scale. These guys are much faster than those, so we could say that Olympic runners finish considerably faster. And we could include, since this graph is so much skinnier than that one, we could say with less variation or spread. So when we're comparing our data sets, we want to look at what is going on in both of our data sets, what shape do we have, and then where do we want to go from there? Do we want to use our mean and standard deviation to compare these data sets, or do we want to use our median and our interquartile range?